Hello, my name is Isaias Ashodono Okupevi, a master's student in cybersecurity department, National College of Ireland. I'm here to present a demonstration, a demo, and presentation of my thesis, which is on detecting fraudulent transactions and network intrusion by utilizing an improved machine learning-based model. Yes, network intrusion and fraudulent transactions are increasing concerns in the field of cybersecurity, and this is gaining traction due to technology advancements. Threat actors use obfuscated means of bypassing our firewalls and IDS or intrusion detection systems, causing various attacks ranging from malware attack, flood attack, shellcode attacks, and reconnaissance attack. However, we'll be implementing a state-of-the-art technology which adopts machine learning. Um, just to give some icebreakers, machine learning, for those who have no idea, is a process that powers many of the services that we use today. You're aware of Netflix, you're aware of YouTube, Spotify, search engines like Google, Bing, social media feeds like Facebook and Twitter. Make use of machine learning. Voice assistants like Siri and Alexa, the list can go on. Well, the place of machine learning is such that it makes educated guess, like highly educated one, of what we want to do next. Maybe we want to listen to a genre of song or related movie, watch the next movie on Netflix, or checking for related research papers on the academic sites. All this revolves around machine learning. So I can say now, moving further, that machine learning algorithms are responsible, or we use such algorithm to find patterns among large data. They are just basically statistical tools. So when I talk about data, I'm talking about a lot of things. I'm talking about numbers, I'm talking about words, images, clicks, name them. So note that anything that can be digitally stored can be fed into a machine learning algorithm. We have various frameworks, for approaching machine learning. So we'll be adopting Yufengo's 7 steps of machine learning. We'll first be collecting our data. Yeah, that's the first thing. We'll be preparing our data. Next step, by removing duplicates, correcting errors, dealing with missing values. Normalization and data type conversion will not be left out. So we're going to visualize our data, to detect relevant relationships or class imbalances. And we're also going to split into training and evaluation sets. We'll be choosing the right model, of course, because we understand that different algorithms are used for different tasks. And remember, our goal of the research um, poses to our research question, which says, how can we prevent against and detect fraudulent attacks and network intrusion efficiently and effectively using a state-of-the-art technology via network signatures? With this, we are going to train our model, to achieve this goal. Next is we're going to evaluate our model. We'll be using some parameter tuning. That's I'm talking of hyper parameter tuning, which may include training steps that we will take, our learning rates, initialization values, which will be set manually. Lastly, we'll make predictions using further tests, set data that we have, and at the end of the day, we'll have an approximation of how um, our model should behave or should perform um, in real mode. So we're going to see the walkthrough, on the product analysis. We can see different packages here. Panda, NumPy, Seaborn, Matplotlib library. We know that Panda is used for importing data sets and managing data sets. NumPy is used because it contains mathematical tools. Matplotlib library is used for making plots. Sklearn is used for importing essential algorithms like regression, naive Bayes algorithm, and many other. So we'll be giving you a walkthrough on our work. Um, we have we are importing all these features, all these packages. Um, we have main max scaler, we have label encoder we use for converting object data to numerical data. We use grid search for tuning our model. We have random forest classifiers, and we have xgboost classifiers. So after that, we have import of metrics to evaluate our model, and we also have variance inflation factor, for which we use to test for multicollinearity. These are the packages that we'll be using for our work today. So going on to the data sets, we have to input the data sets. This is the latest one for fraudulent detection. Now we are getting it to train and test, and we're checking the data frame, all the features here. The next step is to clean the data. The first thing is checking for the missing values. So this is the code for that, and this shows that there is no missing values in our data set. And these are the columns, like what are the data types that we need in our data set. As you can see, there are non-null, there are integer data, there are floats, and there are objects. So we need these objects in our encoders. So we are using this particular visualization, to give us our outliers. We can see that there are a couple of variables here. We need to bring all these variables into our scales. Again, we're checking what our columns are. There are some categorical features. We're checking the numerical ones. So the next thing is we're exploring the target value. 1 means fraudulent and 0 means non-fraudulent. So these are the target values. The next step is on the pre-processing. So one is intrusion or attack transaction, and the second one is normal transaction, which will be recorded as 0. So there are no major in-class balancing, as you can see. So we'll move on. Now, since we have taken the label, we'll be dropping the label from the features. The next step is to encode the categorical features, and we are converting to a numerical form so that we can use it in our model training. There are 3 categorical features: proto, state, service, and we can see that there are a lot of labels, a lot of text here. So we need to convert them using encoding. So um, this method is going to assign 1, 2, 3, 4 based on the category we have for different features. As we see, so we can see different category that we have in the features. For example, in service, you can see that 1, 2, 3, 4, 5, 6, 7, 8, about 10 categories. Then if you are using other category, is going to convert to 0, 1, 2, 3, 0, 2, 5, 9, 7. You can see it is converted into numbers. Now we have used this encoder. We can use other categorical features like state service protocol. As part of this code, we are converting the service and the state. We are converting the state now. We have 6 numbers which are replacing the categories. The final one we are going to be doing is proto. And you can see that there are around 131 unique cases. We cannot use the label encoder for this because it will give artificial bias to this. So therefore, we're going to use a value encoding. Therefore, this code is going to replace this category with how much time it has occurred. So this is a one type of encoding method that we use for many categories in the category features. After this, we have completed our encoding categorical features. The next step is to scale the features. As you have seen earlier, there are many outliers and a couple of features. So we need to bring them into a scale. For that, we're using min-max scaler. The min-max scaler is going to change this and bring it to a scale between 0 and 1. We are using min-max scaler and fit transform to convert this feature. You can see that the minimum and maximum value have been brought into a range. There are two methods of elimination. One is encoding and one is feature selection or elimination. So as part of it, we are going to use RFE, which is feature elimination, recursive feature elimination. So we'll be using a random forest inside this base model into RFE, and we are telling it how much feature we want. Out of 45, only 15 features will be used. I'm telling my algorithm how much feature I want, and I'm providing 15 features out of 45. Out of 45 features, only 15 will be flagged. Now the output from this, you can see true and false. True ones are the ones which are selected by RFE algorithm, and you can select only the true ones for a model. So the next step is only to use the true features recommended by RFE algorithm. Now these are the features: duration, S bytes, The next step is to identify feature correlation or VIF for multicollinearity. So we're going to use our plots from heat map. So we can see that it is ranging from negative value to a positive value. Negative means negatively correlated and positive means highly correlated. We can see there are a couple of values that are highly correlated. So next thing, we are combining this analysis with VIF to identify multicollinearity. So we can see that there are some values that have high correlation number. So this shows that there is high collinearity between these two. So those that have high value in both ones will be removed. And that is this value. We are removing this particular feature because it has high value. After that, we are creating our train and test splits so that we can train and test. This can be done using our train test split algorithm, as you can see. The next step is to build the base model. For our base model, we're using random forest classifier. After that, we are fitting into our X train and Y train, and we are checking the accuracy. And we have an accuracy of 96%. And then we are using confusion matrix to see how much our true positive and false positive is. You can see the numbers here. To support this, we're also going to use metrics dot classification to see the precision and the recall value to see whether they are all balanced. And we can identify that both of them balance up to like 95%. And this identifies that the model is robust. And we're also plotting AUC and ROC curve. Using the MATLAB, we are plotting the diagram and we can see a curve above the random line. And it's a very high value. We have a high IOC of 99. So this is using the random forest based model. The next step is to use the actual data set because we have used a small portion before, I mean the test data set. So that is not the actual data set. For that, we're going to use the actual data set, which is test data, which we had imported earlier. Yeah. So we are going to use that data set. Okay. Yeah. So we're going to use the actual data set. So we have to transform this data set that it is aligning to all our processing steps. We are going to convert category features into numerical features and scale them. So we have to repeat all the processes that we have done for the test data before for this new data set. So once we have done and pre-processed data set, the next thing is to use the data set. We are going to use random forest which we defined earlier to predict this particular data set. And we can see the predictions, we can see the accuracy. The accuracy is around 83%. The previous one has been worked on a small data set, while this one has been worked on a large data set. So let's look at the confusion matrix here. Yeah, and the precision recall and score, we show that it's a balanced one. We are also plotting AUC and ROC curve. The next step is to use xgboost classifier to improve the accuracy. Now we are providing some of hyperparameters here for predictions. We can see that xgboost is giving us about AI accuracy of 85.39 and recall an F1 score. We show that it is balanced. So this is much higher than the random forest, the AUC. So, so to note that are these are manually generated numbers. So we're going to automatically tune them. We provide a parameter dictionary which will tune all these values automatically. And so this will take some time to load. By using this model, we can identify that this is the best model. So the recommendation hyperparameter should be a maximum depth of 5, an estimator of 200. So when we convert this into our model and train it, we will see that there's a slight increase. We'll also be plotting confusion matrix, as we can see, true positive and false positive. You can see that this is 81% and this is 88%, which means the model is more robust on most cases. So finally, we are plotting AUC ROC curve. You are getting 97.98%, which is higher than other parameters. So with all this analysis, we are concluding that xgboost classifier with this set of features can help to give better prediction for which one is fraudulent transaction and which is a normal transaction. And finally, we are also plotting feature importance. As you can see, this one gives importance of which feature is more important. S byte, S mean, the first three. S byte, S mean, CT underscore SRV DST. Now, this is the analysis which we have done. Thank you.